I've seen things you people wouldn't believe. Attack ships on fire off the shoulder of Orion. I watched sea beams glitter in the dark near the 10-house gate. All those moments will be lost in time, like tears in rain. Time to die.
We are sitting at an interesting point, a cusp in history. When we use telescopes, they are extensions of our senses. When we send spacecraft into the solar system and occasionally beyond, it's extensions of ourselves through technology. I believe within a few decades, we will be creating sentient robots that will also be extensions of ourselves. Whether they're cyborgs, robots, artificial intelligence, whether they bear human form or not, they will go places that we cannot go and tell us about them. No different than if we land a Mars rover on Mars and send the images back. Some people find this horrifying, the thought that our progeny will explore the universe and not us. But we are frail, and these machines or humans, or half of each, are our children. So we extend our vision, and we see the universe in new ways. And the history of astronomy is a progression of placing us in lesser and lesser importance in the scheme of things. There's some deep sense of ignominy about the information of astronomy, something that even scientists have trouble getting to grips with. So we've been displaced from the center of the solar system by Copernicus. We found 150 years ago that our sun is one of 400 billion stars in the Milky Way galaxy. We've found since the time of Edwin Hubble that our galaxy is one of billions in the observable universe. And we've even learned in the last few decades that the type of matter we're made of, the stuff of this room and your bodies and the air we breathe, is not what most of the universe is made of. It's made of mysterious forms of dark matter and dark energy. And we're facing possibly the last two frontiers in the continuing Copernican revolution. The idea that biology may not be unique to this planet, but universal, and the possibility, embedded within the Big Bang Theory, that there are other universes out there. Science is discovery, and the nature of discovery is interesting and bears some scrutiny. Sometimes it's not worth scrutinizing it too much. The act of creation, the act of discovery. The poet Santayana said, art critics talk about theories of art, artists just worry about where to buy good turpentine. So we maybe shouldn't look under too harsh a glass at the nature of discovery. But it's an interesting process nonetheless. I wonder if you can see the pattern, describable in only a few words, that describes how these card sequences are laid down. Okay, the top left is obvious. It's a numbered sequence. The top right, a little less obvious. It's alternating color. The number doesn't tell you anything. But what about the bottom two sequences? There is a simple rule in only a few words to describe, and maybe more than one, that says how they're put down. This is the scientist in action, looking at the patterns of the natural world and discovering or discerning the rules. It's not like school. There's no book to look up the answer. Nobody knows. The deliciousness of discovery of a scientist is of being the only person on the planet, perhaps in the universe, to know something for the very first time, to have discovered a pattern that existed in nature. And sometimes the information is not relevant, like the numbers on the top right. You have to know what information is important and what information is not important, and that's part of the art and craft of science. It's the same idea that went behind the discovery of the elements in the periodic table, here given in an alternative form, but it's patterns of nature that describe the way different chemicals behaved and noticing the similarities in the chemical behavior. And this was the basis for the periodic table, but we knew nothing about atoms and the way they behave. That information came much later. But the patterns that are leading us to this deep knowledge of how nature works, are like a puzzle. They're like a game. We should embrace the fact that it has the elements of a game, because science is fun. Another part that's harder to understand is the role of mathematics in the natural world. Nature is rife with the deep patterns of mathematics, embedded in ways that are profound and surprising even to scientists. This, of course, could go on forever, because it is an endless zoom into the Mandelbrot set. That previous pattern, something I'm sure you're familiar with, is amazing because it's describable by a single equation, a single mathematical equation that's only one line long. It does involve the magical entity I, the square root of -1, but otherwise it's among the simplest of equations. That equation, turned into 2 dimensions and animated with an endless zoom, unleashes worlds that you can barely imagine. They go on forever. They're embedded in that equation. Are they in the real world? We can represent them. Is the Mandelbrot set and the infinite worlds it encompasses, are they invented or discovered? The mathematician Roger Penrose came down firmly on the aspect of discovery. He said, the Mandelbrot set is like Mount Everest. It was just there, waiting to be discovered. And so is science discovery or invention? Is it an imposition of the human mind or something we find in nature? We might think that it's something we find in nature. But what about art? Is that invented or discovered? Well, we get a slightly surprising answer by reading the sonnets of Michelangelo that describe his process as he sculpted. As a young man, Michelangelo would scramble along the ledges and hilltops of the marble quarries of Carrara and select the marble that he would carve. Those of us who are not artists find it inevitable to believe that the magical act of an artist is that of imposing his or her will on the stubborn block of marble, of creating something incredible from something that's like a cube or a rectangle. But that's not the way Michelangelo described it. The reason he scrambled over the quarry sides was because he was looking for a rock within which something was trapped that he could liberate by his artistic efforts. That's exactly the way he described it. The life form, the vividness of what was in there was real, and he was just liberating something already present. So we can subvert the distinction between invention and discovery both from the point of view of science or from the point of view of art. Science is obviously about imagination. Einstein famously said, imagination is more important than knowledge. Again, an easy thing to say when you know as much as Einstein knew. And he, of course, suffered through one of the most stultifying education systems in the world, in Germany, in his youth. So he had plenty of reason not to be happy with the way he'd been taught. But it's true. Imagination is the heart of science. Without that, there is nothing. And obviously, it's the heart of all art. Imagination is important because, again, it takes us places that we haven't been, but one day might go. And it's surprising. The imagination that juxtaposes two everyday pieces of an everyday object and produces something new is true creation. Scientists can do this too, and we have to recognize that what's possible and what's impossible that's not necessarily a meaningful distinction. This is impossible music, for example. When we hear music for a player piano that's impossible for a person to play, does that make it less musical? We have to use our imagination to take us to places we can't yet go. Newton imagined orbits 350 years before we invented spacecraft by hypothesizing what would happen if you launched a cannonball from the top of a mountain with sufficient speed that the Earth's surface fell away at the same rate that the cannonball fell. Voila, an orbit. Space artists imagine other worlds, other Earths, other planets that might harbor life, decades before we'll be able to send our spacecraft there. And as I said, sometimes we can imagine places where we'd like to go and one day might go, but our technology doesn't yet let us take us there.
Okay to go. I'm okay to go.
Initiate drop sequence. On my mark. 10. 9.
Now we transfer.
8. 7. 6. 5. 4. 3. 2.
I'm okay to go. I'm good! Alien control! Alien control! Do you read me? Alien control! Do you read me? I'm gonna try and keep recording! I'm going through some kind of a tunnel! There's a light source ahead! Brilliant! Blue-white! Is this all radiation?
She was traveling through a wormhole. You will be interested to know that the laws of physics do not rule out wormholes. And some very esteemed physicists and gravitational theorists have hypothesized the interconnectedness of space and time that might lead to such travel. It's not an idea of pure science fiction. It's something that might eventually happen. And Trekkies out there will be intrigued to know that there is no physical objection, no fundamental problem in the laws of physics to teleportation. It used to be worried that the quantum state of a human, a complex organism, could not possibly be recreated at a remote location. But there's actually no obstacle in physics to movement at the speed of light and recreation, quantum state by quantum state, of a complex entity. We just don't have the technology to do it. That's the hard work we have to do. The imagination was already there. So how has this business progressed, the business of science that leads us to such an amazing view of the universe? And along the way, can we learn some of the modes of work of a scientist and again see how